probability that a person at random has red hair is 0.02, so that's 2%. Two people are chosen at random. What's the probability that at least one has red hair? Well, if we just want to think about, so we can do this easily, but let's think about it and let's think about why we can get the answer. So if we draw a tree diagram, we have two possibilities. We've got, let's just do NR for not red and R for red, right?
Yeah.
So this is for your first person. And then for your second person, we've got the same choice again for red and not red. And same here, right?
Mm-hmm.
So we want that at least one was had red hair. So either they can have both red hair, the first one could have red hair, or the second one could have red hair, right?
Yeah.
So what we're going to do here is we're going to use the complements of the event. So if we want to find out that at least one of them has red hair, we could add these three probabilities together and find them. Or we could just do this last one and subtract this value from 1, so 100%, and that would give you the probability that that's not true.
Yeah, I think because I was doing a similar question for a different one. I think it was for the 2014 HSC. And I think there was a probability one in that one. Sorry.
Yeah.
And yeah, I looked it up and it said that if you want to find one for at least one, you should just do the probability of not having any like one minus that.
Yeah. So what's the probability that we get two people that don't have red hair?
0.98 squared.
Perfect. So it's going to be 0.98 times 0.98 or 0.98 squared, right? And then we go 1 minus that. So let me just get my calculator out, and 1 minus 0.98 squared. So we should be getting about almost 4%. So it's 0.0396.
Yep.
So that's going to be approximately, not quite. In an exam, you do the exact version, but it's going to be about for 99. Oh, sorry, not 94%. I'll just do the exact version. Oh, sorry, that is the exact version. Sorry. I wrote that wrong. So that should be 0.98 squared, which equals to 0.0396. Does that make sense?
Yep.
Yeah. So then what is the smallest number of people that can be chosen at random so that the probability that at least one has red hair is greater than 0.4?
So is that where we go 1 minus the chance of none squared equals 0.4?
Yeah, so we go 1 minus, so this is the chance of none to the power of n, because that's what we're trying to find, the number of people.
Oh, yeah.
Equals to 0.4. So from here, we're going to use logs and exponentials. So we go, this is actually a really good question. I quite like this. So let's just say I'm just going to move this over and then move my 0.4 over. N equals to 1 minus 0.4. Does that make sense?
Yeah.
And then we're going to use L log of 0.98 bracket 0.6 equals to N. And then from there, I'll go up here. N equals to ln 0.98 all over ln 0.6. So what have I done here? I've just used my change of base formula.
I thought it was the other way around.
Oh, sorry, it is. Sorry.
Yeah, all good.
My mistake.
I only remember that because I had raised an ln related question.
Does that make sense?
Yeah.
And that's how you do it. And that'll give you the number of people needed for a chance of greater than 0.4. Now, that doesn't mean you're going to get a person with red hair. You could do it 1,000 times and get no one with red hair. It just means that you've got a 40% chance of getting someone with red hair, or greater
Yeah.
than 40% chance. So n would have to be bigger than. So here you're not going to get a whole number, but you want to round that up to the next whole number, because that would
Okay.
give you the smallest number of people.
Okay.
And why are we rounding up? Because if we were to round down and sub it in, the probability would be less than 0.4.
Yeah.
So we have to round up.
Okay.
That makes sense?
Yep.
Awesome. So we might actually leave it there for today.
Okay.
So I will maybe see you again, not so much see, but more hear you again next Friday.
Mhm.
And if not, we'll have our lessons on Sunday. But for this week, I want you to do the test yourself sections and the challenge exercises for the questions I posted
Okay.
in the last chat. So yeah, so if you didn't download all of them, let me know. So there's the 3 further differentiation.
I think I didn't download chapter 10.
Oh, yeah.
Chapter 10. The chapter 5. Sorry.
I'll send them to you then, so don't worry.
Okay.
But I want you to do those for homework, because that'll help you in your exam, because that's what your exam's about. And don't do the questions about projectile motion or the questions about proving things, because that will not be in your exam.
Yeah.
Yeah. So other than that, I will. Oh, yeah. So those are your learning goals. So this week, I want you to essentially just study for your exam and learn how to work with those vectors and do those sorts of inverse trig questions in particular, but inverse functions in general as well.
Okay.
So for the chapter 5, just do the extension 1 questions, because those are the ones you'll be tested on.
Okay.
Yeah. But for vectors and further vectors, both of those are just extension topics. So all of the questions can be tested except for the proof and the projectile motion ones.
Yep.
Oh, yeah. So does all that make sense?
Yes.
And if you have any questions from any of those sections, message me and I'll get back to you. Okay?
And I'm just thinking, because Xiong said that a lot of the geometry related stuff is not going to be in it. Would 15C be in it?
Yeah. So that you're talking about the C for this exam?
Yeah.
It should be, because this is the first HSC with the new course, I believe.
Oh, because they still have Simpson rule.
Does it? Oh.
Yeah.
I'll look into it and I'll get back to you, because to my knowledge, this was the first exam that had the new course. Oh, wait, maybe, no, maybe you guys are the first that have the new course. No, I think you guys are, never mind. Yeah, so this one shouldn't be in it. Yeah, I think you're right, yeah. Yeah, so this one shouldn't be in it. But that's how you do it anyway. So it's just similar triangles again.
Yep. Okay.
Yeah. Normally, if you see triangles and they're asking about squares, it's normally something to do with Pythagoras or something to do with similar triangles.
Okay.
Yeah.